Alright, so on this one, section 4.3, we talk about the inverse function of e to the x, or a to the x. We know that we had a function a to the x. Now this is what the inverse function of that is called. It's called the logarithm. So now the definition of a logarithm says if y equals log base a of x, that's how you read that, log base a of x, then a to the y equals x. So now you can take something that is a logarithm and write it in exponential form, or you can take something that's an exponential and write it as a logarithm. And what you find is that if you start with one and you can't figure out the answer, if you write it in terms of the other, you can. Alright, so notice the logarithm, base a, equals y. And notice over here y is your exponent. That's what logarithms are. Logarithms equal the exponent. The exponent is all that logarithm is. And so a to the y equals x. You can curl it with an arrow around there, so a to the y equals x, to help you to remember what the exponential is. So they give you some examples here. Log base 10 of 100,000 equals 5. That means 10 to the 5th equals 100,000. Log base 2 of 8 equals 3. That means 2 to the 3 equals 8. Log base 2 of 1/8 equals negative 3. That means 2 to the negative 3 equals 1/8. And it does, because 2 to the negative 3, when you cross the fraction bar, it's 1 over 2 to the positive 3, which is 1 over 8. Alright, log base 1/3 of 9 equals negative 2. That means 1/3 to the negative 2 equals 9. Now they ask you to justify that log base 10 of 1,000 equals 3. Well, it is, because 10 to the 3rd equals 1,000. Log base 2 of 32 equals 5. It is, because 2 to the 5th equals 32. Log base 10 of 0.1 is negative 1, because 10 to the negative 1 equals 0.1. Log base 16 of 4 equals 1/2, because 16 to the 1/2 equals 4. And log base 1/2 of 16 equals negative 4, because 1/2 to the negative 4 equals 16. So if you don't know what a log equals, write it in exponential form and you can figure it out. Okay, so there's 9 rules for logarithms. The most important one is rule 1. Okay, rules 2 and 3 we'll see in the next section, 4.4, but for right now, log base a of x to the n equals n times log base a of x. So you can bring an exponent out front. And you can always go in the other direction. You can bring the number in front into the exponent. And also log base a of a to the n equals n. That means when these two numbers match, the base and this number match, the answer is just the exponent. You'll be using that a lot. Log 5, or the 5th rule isn't used that often. Log base a of a equals 1 because of rule 4b here. If you got these two match, the answer is the exponent, which is a 1 here. Log base a of 1 equals 0 because a to the 0 equals 1. Anything to the 0th power equals 1. So when you take the log of 1, no matter what base you have, it's always equal to 0. And this is a weird one. A raised to the log base a of x equals x. So if you got this guy and your exponent is a log with the same base, your answer is just that number there, the x. Then finally, change of base formula. If your calculator can't do the log base function, which you find by doing by typing in math, type math and then arrow down to A, and when you hit enter you get log base, and that will allow you to type in any base you want and any number you want. If you don't have that, you can change your base easily by just changing it to a base that you want. Now, your calculator can only do 2 bases, base 10 and base E, so don't change it to anything else, otherwise your calculator won't do it. So, whatever your base is, change it to log base 10 over log base 10 or log base E over log base E. The x goes above and the b goes below. Alright, and so here are some examples of some rules here. So they say log base 5 of 1 equals 0. We just said that. That's rule 7, 7a. There's actually 7. Log base 5 of 5 equals 1 because the exponent is 1 there. Remember, when those two match, the answer is just the exponent. Log base 5 of 5 to the 8 equals 8. That rule you'll use a lot, which says that these two bases match. The answer is just the exponent. And then this one is that weird rule 8. 5 raised to the log base 5 of 12 equals 12. And that's rule 8. Alright, so they ask you to graph it. And so you fill out a table. Now when you fill out a table, you remember if you let x be powers of 2, your log is just the exponent there. So if you let x be 2 to the third, 2 to the second, 2 to the first, 2 to the 0, all the way to 2 to the minus 4, then your y values are just from minus 4 to positive 3. It's whatever the exponent is. And when you graph that, you end up getting this. So it has an asymptote at x equals 0, vertical asymptote at x equals 0. It goes to the right forever, but it stops, it only goes to the left to greater than 0. So your domain is greater than 0 to infinity. Your range is everything. It goes to up to infinity and down to minus infinity. Notice it crosses at 1, 0 instead of crossing at 0, 1 like 2 to the x did. Now if your base is some number greater than 1, like 2, 3, 5, or 10, it's going to shoot off to the right, and the greater the base, the lower it goes. And now if your base is a fraction, notice that it shows almost like decay. It's going downward from left to right. Now like I said, the log base a of x is the inverse of a to the x. So if you got a to the x, looks like this. We're talking about greater than 1 here. A to the x, log base a of x equals this, and they're pivoting on the y equals x axis. They're inverses of each other. Okay, so if you were to graph a general form of log base a of x for greater than 1, it's going to cross at 1, 0. It's going to come down here and get infinitely close to the y-axis. It's going to come up here and grow more and more each time. So your domain is greater than 0 to infinity. Your range is everything, minus infinity to infinity. Your x-intercept is 1, 0. It doesn't have a y-intercept. And it's got a vertical asymptote at x equals 0. So what happens when you look at, if you graph log base 2 of x, we know that it crosses at 1, 0 and shoots up to the right like we'd expect. But if you want to graph negative log 2 of x, it's going to pivot on the x-axis. Alright. Now if you take log base 2 of x, this guy here, and you put a negative on the inside of the function, it flips on the y-axis. Alright. And then if you take log base 5 of x, which we know crosses at 1, 0 and goes up to the right, if you add 2, everything moves up 2 units. And so it moves up 2. Now there's two different logarithms your calculator can do. There's log base 10 and there's log base e. Log base 10 is sometimes called the common log, and because it's the most used logarithm we're going to use, we don't have to write the base. So whenever you see log without a base written, you can assume it's 10. Alright? And so the basic rule here says log of x, or log base 10 of x equals y. That means 10 to the y equals x. Okay, so if you plug in a 10 into this, you get 1. You plug 100 into this, you get 2. The natural log is log base e, but you don't have to write log base e. You can write ln, which is the French for log naturel, which is natural logarithm. Okay, and so ln of x equals y is the same thing as e to the y equals x. Alright, so that's the other logarithm your calculator can do. Now the rules for base e are the same as the rules for base 10. It's just we're using an e instead of a 10. And instead of writing log, we write ln, because that's base e. The rules are exactly the same. And then number 9, they ask you to calculate what ln of e to the x is. ln of e to the x is just 8, because if the base e and this number match, which is e, the answer is just the exponent. That's by rule 4, I believe. Alright, ln of 1 over e to the x is ln of e to the negative 2. You cross the fraction bar, it becomes e to the negative 2. And your answer is just the exponent, because the base and this number match. Now ln of 5, you just type that into your calculator. You find ln just to the left of the 4 on your calculator key. So you got f of x equals log base 9 of x. It's a logarithm with base 9. Now they ask you to plug 9 into this function. Well, it's log base 9 of 9, so the answer is just the exponent 1. Plug a 1 in there, log base 9 of 1. Remember I said log base anything of 1 always equals 0. F of 1/9 is log base 9 of 1 over 9, which is 1 over 9 is 9 to the negative 1. When you cross the fraction bar, that positive 1 exponent becomes negative 1. And now they match, so your answer is just the exponent. 81, that's 9 squared, right? So these two match, the answer is 2, the exponent. 3 is a little tricky, but you can write 3 in terms of 9 as 9 to the 1/2, meaning the square root of 9. And since those two match, the answer is just the exponent 1/2. Okay, now here they ask you to match up the logarithm with each one of these guys. Well, we know the most basic log base 2 of x crosses at 1, 0 and goes off to the right, so that's a. Okay. And then if we put a negative in front, it's going to pivot it on the y-axis, so this one is the pivoting on the x-axis, negative log base 2 of x. And then if you put a negative in front inside the known function, it flips it on the y-axis, and so that would be b is it's graph 2. And this one with a negative out in front and a negative in the exponent, you're pivoting it on the y-axis and the x-axis, and so that's what that one looks like. Now each one of these they ask you to calculate, and a lot of times it's just a rewrite of whatever the base is. So log base 5 of 1/5 is negative 1 because 5 to the negative 1 equals 1/5. Okay. Log base 1/5 of 5 equals negative 1 because 1/5 to the negative 1 equals 5. Okay. They're asking you to rewrite these. Log base 8 of 2 equals 1/3. That means 8 to the 1/3 equals 2. Log base 10 of 0.01 equals negative 2. That means 10 to the negative 2 equals 0.01. And the same thing here. ln is base e, so e to the 3 equals x minus 2. E to the 1 equals 2x minus 3. Okay, now here they want you to rewrite these as logarithms. So base 6 of 36 equals the exponent 2. Base 10 of 1/10 equals the exponent negative 1. Log base 4 of 0.125 equals the exponent negative 3/2. Log base 1/2 of 8 equals the exponent negative 3. Logs always equal the exponent. Okay, and log base e of 0.5 equals x plus 1. Log base e of t equals 0.5x. And 25. Ask you to figure out what this is. Log base 2 of 2. Well, the answer is 1 because the exponent is your answer. When these two match, the answer is whatever your exponent is. And then log base 5 of 1. Log base anything of 1. Log of 1 always equals 0. Log of 1/2 equals of 2 equals log base 1/2 of 1/2 to the negative 1. You can cross the fraction bar and write that as 1/2 to the negative 1. And that equals negative 1. So it's just the key here is to write this number in terms of your base, and then you can see what the answer is.